Okay, here's a problem from homework number 18 that's a little different because rather than being given the summary statistics, we're actually given the raw data. So this is a great problem to look at. I'm not going to go through all the reading, but we're basically told a simple random sample of pages from a dictionary is obtained. There's a lot of words here, but I'm just going to jump right to the claim. What we're asked is the claim that the claim here that the average number of words on a page in a dictionary is greater than 48. That is our claim right there. And we need to use a 0.1 significance level. Now, instead of giving us the sample mean and standard deviation, we're just actually given the average number of pages, or the number of words, the number of words on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different pages in a dictionary. So n equals 10, and we now need to actually write that down here, n equals 10. We're going to actually need to find the mean and standard deviation ourselves. So this is actually a little review of chapter 3, way back in chapter 3, which is great review for the project that's coming up. So let's go through our steps of how we test a claim. We start with our null hypothesis, which is always in the claim that the mean number of defined words on a page is greater than 48. Since our null hypothesis always has to be the equality, we are going to say that the null hypothesis is that the mean number of pages will equal exactly 48. And therefore, our alternative hypothesis will be the claim that, in fact, the mean is actually greater than 48. Our claim is right here. Okay. All right. Step 2 was we can't move on and find the test statistic until we know the mean, the sample mean, and the sample standard deviation. So how do we do that? Well, we have to go back to chapter 3. We actually have to plug these numbers into our calculators and find the mean and standard deviation, or we can use StatCrunch. So just a quick review. I'm going to actually pull this problem up. And on your problem in the homework, you can click on the little table to the right and just put this data right in StatCrunch. You go back to chapter 3 StatCrunch tips. You will remember that to find mean and standard deviation, we open stats and then we open summary stats to columns. Our data is in this var1, and all we really need for this one is the mean and the standard deviation. So let's go ahead and compute that. And here we go. We've got a mean of 57 and a standard deviation of 14.12. I'm going to close that out, and I'm going to go ahead and write that down. We have a sample mean of 57 and a standard deviation of 14.12. So we actually had to calculate that ourselves. One extra step from previous problems, but we know how to do that. Okay, so what's going on in step 3 now? Step 3, we see the graph. This is where we plot our critical value and our critical space. And in this case, they want us to use a t-table and a t-statistic. So we are told that the critical value is a 0.1 significance level right here. There's our critical space, actually. And now, because we are greater than, we have a right-tailed test. It's a pretty big significance level. So we know that this area here is now 0.01. I don't even need to carry it out the 4 places because we're not going to a z-table. We are going to the t-table. Okay. All right, let's see if we remember how to do this. Let me close this out and open up our t-table. Let's see here if I can find it. T-table. Nope. Where was it? Nope. Let's close that. Let's see. Somewhere here. Nope. Where was that t-table? I think, no. Here it is. Okay. Here's our t-table. And again, it's in your packet. But okay, so we know we have a one-tailed test, and we need a significance of 0.10. So we're right there. We're in this column. We know n was equal to 10. We were given 10 pieces of data, and so therefore our degrees of freedom is equal to that 10 minus 1, which is 9. So we're going to go to 9, the number 9 right here. We're going to go on over to all the way over to the right to this t-value here, which is t equals, I know it's tiny, but it says 1.383. Okay. Let's close that out and go back up here to 6. Question. Okay, so let's go ahead and plot that. T was a value of 1.383. Okay. Stays positive because we are to the right of the mean. All right. Next step, find that test statistic. And so in this case, because we're doing a t, it's the same exact formula. We're still going to take that sample mean, which we found to be 57, minus our mean of 48, okay, divided by the standard deviation of 14.12, divided by the square root of our sample size, which was 10. Carefully plug all that into your calculator, and it should spit out 2.016. If you're having trouble with your calculator and getting the right numbers, please come see me, because it's usually just one or two issues with the order of operations. Okay, so here our mean was 48, and now we're finding, plotting our test statistic, which you can see is to the right of our mean. It's positive. It's past 1.83, and it's right here around. Here is our test statistic. I should mark that as our critical value. Here's our test statistic, and this is a t-value of 2.016. Okay, so in fact, now our test statistic is in the critical space, so therefore our conclusion is we are going to reject the null. And I think it's always important when you do reject the null to go up and actually reject it. Draw a line right through it. Because we can cross that out, then we actually can accept this claim here. Therefore, and I believe the homework writes it, there is sufficient, I often write the word enough, evidence to support or accept, however you want to write that. When you're writing it out in your homework, it's either one is fine with me, to accept the claim that the average number of pages in a dictionary, the average number of words on a page in a dictionary is greater than 48. Okay, how do we do a problem like this with technology? And if you go ahead back to our original problem here, when we put this into StatCrunch, we can put this again into StatCrunch, and rather than finding the mean and standard deviation and doing it by hand, you will also notice that you can go to, same as we've always done, we go down to ZStats. It's still one sample, but notice here when you have this on now, and we usually click on with summary, but we weren't given the summary this time. We were actually given the data. So the only difference is you click on with data. And where is that data? It's right here in the first column. And then everything else is the same. Our null hypothesis was that the mean number of words on a page is 48. And the alternative to that, which was the claim, is that it was actually greater than that, 48. We'll go ahead and compute it, and sure enough, there's that test statistic that we calculated by hand, 2.0158. We rounded up. Okay, so again, especially when we get into problems where you have tons and tons of data, you're going to want to be able to use technology. Okay, all right. Oops, let's go ahead and work on those problems. You can do it.